Have you ever heard the old Boy Scout rule, always leave the campground cleaner than you found it? Well, as software developers, we want to adopt a similar rule. Every time we make a change to our code, or someone else's code, we want to try and clean it up or improve it in some way. We don't want to necessarily make big, massive changes, but if we see an opportunity to, let's say, use a variable instead of a hard-coded value, then we should make and test that change. The important thing to emphasize here is that we don't want to change the behavior of the code. We're just looking for opportunities to make it a little cleaner and more efficient, or maybe maintainable for someone else to work with in the future. This process is known as refactoring. Let's see how to do it with our crystal ball code. Right now we have all of our code in the main activity class. It's working fine that way, but what if we wanted to add a new screen that also randomly selected one of our answers? We could copy all this code and then add it to the new screen activity, but then we would have the same code doing the same thing in two different places. Then if we change this code for some reason, we'd have to remember to make the same change in the other code for the other activity. This violates a core principle of software development, the don't repeat yourself, or DRY principle. A better solution is to move the code that is repeated to a reusable component. In this case, that would be a new object that can be used in multiple activities. We learned before that Android activities are used to control how things work on the screen. This code does that, but it also controls how the answer is generated behind the scenes. Let's make a new object that separates this functionality out for us. Not only will it make our code a little cleaner, but it will also prevent us from repeating ourselves in code. And it will give us a little more practice with objects, which is important for Java and Android development. It's considered good programming practice to give each class a single responsibility. So in our case, the main activity will handle only how the screen looks and works, and the crystal ball class we'll create will handle how an answer is generated. This is a principle known as the single responsibility principle. Start by right-clicking on the com.example.crystalball package in Package Explorer. Then select New, Class. Notice that it's going to be placed in our source directory with our other classes, and it has our package name already filled in. Type here in the name Crystal Ball, no spaces, and leave everything else as is. Then click Finish. The crystalball.java file was added over in the Package Explorer, and the file was opened over here in our code editor view. This code will be the blueprint for our crystal ball object. Remember that an object has two main components: properties about the object, and methods or abilities it can perform. The ability for this object will simply be to get an answer, so let's define a method for it. Type public string getAnswer. Type a parentheses, an open curly brace, and hit enter. Public here and here means that this class and its method will be available to anyone. The string keyword tells us that this method will return a string data type when it's all done. Now let's cut and paste some code from our activity class into here. Select and cut lines 26 through 49. Switch back to Crystal Ball and paste that code in the getAnswer method. This code gets a random element from the answers array, but we need to let the code that called this method know what answer we choose. We said that this method will return a string, so that's exactly what we'll do. At the bottom, type return space answer with a semicolon. Return is a special keyword that says, I'm done with this method. Here's the result. The result in this case is the answer variable, which has to be a string. It's declared as a string on line 21. If we try to return a different data type, like the number 3, then Eclipse will give us an error. Type mismatch, cannot convert from int to string. Let's go back to our activity and use this new method. First, we need to instantiate a crystal ball object. We're going to use this object to do the work of getting an answer for us when the button is tapped. Now we could do it here in the onClick method, but if we do that, then a crystal ball object will be created every time we tap on the button. That seems inefficient, doesn't it? What if our crystal ball object were big and complex, with thousands of answers to choose from? That means we'd be wasting processing time in recreating the crystal ball for each tap. Instead, let's do it one time and make it available throughout the life of our app. This way, we only have the overhead of creating a crystal ball object one time. Up here before the onCreate method, type private crystal ball, lowercase m crystal ball, equals new crystal ball, a lot of crystal balls flying around here, open and close parentheses, and a semicolon. This constructs a new crystal ball object named mCrystalBall. Notice that we didn't have to add any constructor code for this new crystal ball object. We're using the default constructor, which doesn't really do anything besides construct the object for us. Now, this mCrystalBall is a property or member variable of our main activity object. Properties about objects are typically called member variables in Java, and the standard naming convention is to prepend a lowercase m, which stands for member variable. This lets us know at a glance that a given variable is a class member variable. Member variables should be declared public or private like methods too, so that's why we have the private keyword here. Private means that this member variable is only available and visible to this class. We can't access this crystal ball member variable from anywhere else outside of the main activity class. Back in the onClick method, let's get an answer from our crystal ball object. Type string answer equals mCrystalBall, and then hit dot for IntelliSense. Cool, there's our getAnAnswer method. But where did all these other methods come from? We didn't write those. Well, in Java, every single object by default inherits basic methods from something known as the base object class. You can see the object name over here to the right of each method. And to the right of our method, it says crystalBall. Don't worry about this too much for now, but that's just why we see more here than the method we wrote. Okay, hit enter, add a semicolon, and we're done. Well, sort of. First, notice that there's a new yellow warning at the top of our screen. Because we moved some code into a new object, we need to clean up our import statements using Command-Shift-O for a Mac or Control-Shift-O for Windows. All right, let's review our code here in main activity. First, we create our activity and then hook it up to the activity main XML layout. Then we declare our view variables and attach them to views in the layout through their IDs. Next, we set the onClick listener for our button, and when the button is tapped, we get an answer from our crystal ball object and then update our label. Pretty streamlined. Let's make one more pass on the crystal ball class. I'm going to save main activity, but now we have an error here at mCrystalBall.getAnAnswer. Let's come over here and take a look. That's because we haven't saved our crystal ball activity. Let's save it, and now if we flip back, we'll notice that the error has disappeared. Looking at this code here, we see one of the main problems with using comments. We ideally want to write code that is easy to understand without additional comments. Comments tend to be forgotten about after they're first written, and they can end up not making any sense, like some of these. We're no longer dealing with a button in this class, so let's delete this comment. And then let's clear out this comment as well. I want to make one more change to further explain how objects are typically used. This object doesn't have any member variables yet. It's a plain old crystal ball that can do one thing. Now, we could invent some properties like color or size, but instead, let's use our array of answers as a property. The list of potential answers is something about this crystal ball. So let's cut the answers from this method and paste it up here in our class declaration. Remember that member variables should be declared public or private too, so let's make this one public. Also, let's follow the naming convention where member variables begin with a lowercase m. Right-click on Answers, then select Refactor, Rename. Type manswers as the new name and hit enter. That will change the name answers to manswers wherever it appears. Notice that it changed here below in line 25. So now our crystal ball object has one member variable, the list of potential answers, and one method, the getAnAnswer method, which randomly selects one of the potential answers. Let's save our changes here, and then flip back to the main activity to see this property in IntelliSense. On a new line, type mCrystalBall, and then hit dot for IntelliSense. Now the first item is our manswers member variable. You can tell which items are member variables because they don't have any parentheses after their names. All the other items in this list have parentheses indicating that they're methods. We can use the manswers property just like a regular variable. For example, we could change the value of the first item in the array by typing manswers open square brackets 0, then setting it equal to some text value. But we always need the object name before the member variable name. If I delete mCrystalBall and try to access manswers by itself, Eclipse will show me an error because it no longer knows what manswers is. All right, let's delete this line, save, and test it out. Remember that the goal of refactoring is to make changes to the code without changing the behavior of the app. So if we tap on the button, it should work exactly like it did before. All right, looks pretty good. Our app is really shaping up nicely. We're using the random object to generate a random number. We have an array of strings to store all our possible answers. And we refactored our code to better organize it and follow some good programming conventions. Next, we'll liven it up with some nice images, sounds, and animations. We'll make it so that you can show it off at parties and say, I made this.